Hey everybody, and welcome back to Algebra 2 Online. So this is the first video in a series of review videos that will cover all sorts of important things from the course so far. So all of these problems I'm picking out are really the ones that I think you definitely want to know. There's lots of other stuff that will be left out, and just because it's left out doesn't mean it's not important. It's just that these are the things that are super important that you definitely want to understand. So one of the things we did way back, I think we did it this in November or so, early November, or maybe late October, but that just kept showing up. It shows up literally in chapters 5, 6, I don't know if we actually saw one in 7, but definitely 8 and 9 is quadratic inequalities. You definitely want to know how to solve these. And the way I basically do it is you want to find the roots first, okay? And then you make like a rough sketch using the roots and the sign of A. And then just looking at that picture, you answer the inequality with typically an and or an or kind of inequality, right? There are some where you can get like no solution or all real numbers or something like that, but this is like our typical kind of plan of attack for these. Typically, too, I like to get A to be positive, but this one is already pretty simple, right? Because you literally just have an upside down quadratic shifted down 10. So, you got something like that where that's negative 10. This is one then that if we were asked when is that quadratic less than 0, it's true for all real numbers, right? So you can just put like the little all real symbol. So that's one that's actually not like an and or an or. It's kind of a weirder one, but a lot of them are and or ones. But yeah, that one, you don't even need to find the roots actually, because you can just get the rough sketch just based on function transformations. And then you can see that it's all reals because everything you plug in will make it less than 0. This one, you do want to find the roots, definitely. And the roots are not super easy. You'd have to do the quadratic formula. The roots would be from the quadratic formula 5 plus or minus root 57 over 2. And so if you went and, kind of think about what that looks like, 5 plus root 57, whatever that is, over 2 is one root, and then like 5 minus root 57 over 2 is another. And so you get, an open up kind of quadratic because A is positive. And if you want to talk about where this picture is greater than 0, this is my, 0 line that I'm talking about, I need to describe these chunks over here, right? And so that would be like an or. It's not an overlapping region. We would basically say x needs to be less than the 5 minus root 57 over 2, or x needs to be bigger than the 5 minus root 57 over 2. So, that's kind of a standard answer, I would say. These kind of things where you just find the roots, and it's greater than 0. In this case, you do less than the small root, bigger than the big root, that kind of thing. All right, just one more. Again, you'd have to do, you try to factor it or do quadratic formula. If you do quadratic formula, you would have x equals like 6 plus or minus 36 minus 4 minus 2 times 7. And then it's all over 4. And what's important here, 4 times 2 times 7 is bigger than 36. So really all I need to know is that this is a negative number in here. And if that's a negative number, it means that in the picture, right, the quadratic is doing something kind of like this. The quadratic opens up because A is positive. And the roots are imaginary, right? And we know that imaginary roots are just ones where it doesn't like cross the x-axis like this, at least where we can see. So if we want to know when is it less than 0, you can see from this picture it's not less than 0 ever, so we just say no solution. That's the other kind of weird case, kind of along with this one that you can get. And that's it. So these are definitely really, really important. You want to make sure you understand how to do those. They're going to show up in some form on the final. All right. This is another really important thing, these application problems with log and exponential stuff. So you definitely want to know how to do these. I was pre-med in the beginning of undergrad, and I used to do problems like this in some of my med classes, and they're just exponential log kind of things. They're pretty straightforward once you see kind of how they work. They all have the same feel to them, I guess. So this one says that a medicine has a half-life of 6 hours. So, half of the medicine kind of left through the bloodstream there after 6 hours, okay? And if a patient is given 600 milligrams at noon, what time do they have 100 milligrams remaining? And these are very real-life problems. A lot of times you need to know when to re-up someone's medicine, and maybe at 100 milligrams is the time to re-up it for whatever reason, and so you need to know like roughly when to go into the patient's room and give more medicine. That's like a very normal thing that doctors do. So for this, we basically use one of those kind of exponential decay quantity equations. So what I mean by that is this. This is end amount of quantity as like a function of time. This is the initial quantity, and E is just that base we use for the exponential growth and decay, and then rate and time. You always have to use the half-life somehow in these problems. So, it's saying that if you started with like 1 milligram of this stuff, you would have a half. It would like degrade to a half after 6 hours, right? So you can solve that for the rate. And, to do that, you take natural log of a half, or natural log of both sides, and then you get minus 6r over here. And then divide by negative 6, r would be approximately 0.1155. And so that is going to become handy for us. We're going to need to go to back to this kind of equation, but this time actually like plug in, the rate now. So we have the end amount is 100. Right? We have 100 milligrams remaining. Started with 600. We know the rate now is about 0.1155, and then the time is what I want to know. I want to know at what time do they have 100 milligrams remaining in their bloodstream. So divide by 600, right? And you would get 1/6 equals e to the negative 0.1155t. Take natural log of both sides, and then negative 0.1155t. And then you divide by that rate. And, I'm really, when I do these, I'm not actually, rounding these things. I write it here just because it goes on and on forever, that decimal. So try to just keep the answer from here on your calculator and then divide it in here without rounding, in here. You'll be close if you round, but you will be off a little bit if you do round. So try to just never round until like the very, very end. So if you do that, you're going to get t, if you divide by the natural log of 1/2 divided by negative 6, right, from over here, the rate, t ends up being approximately 15.5, and that was hours, right? And so the question is, like, basically, when do you go back into, like, the room to re-up their medicine, let's say? Then you know that 15 and a half hours after noon, it's going to be down to 100 milligrams, and maybe that's, like, the nearest time that you need to go in there. So, 12 hours from there would be midnight, and then you go 3.5 more hours. So you're at, 3:30 a.m.? So 3:30 a.m. is basically the nearest half hour. That would be when you have 100 milligrams left. So very important problems to know. I really am trying to stress these because they may or may not show up on your final. Hint, 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 hint. No. All right. Another just really important problem that you could see is graphing piecewise function stuff. So these are good because there's so many different functions I could basically ask you to graph in these problems. And so in that way, it's kind of a nice thing that uses different things from the year all in one problem, which is good. So this one just says, first we're going to just graph this piecewise function, and then I'm going to ask a few little function questions based on that. So we have like, even actually some of these you can answer right now. Actually, let's just to kind of, we'll just graph it first. So let's just start by graphing. So this one is just a quadratic, right? There's an open up quadratic shifted to the left 2 because it's plus 2 in there. So over at -2 is where it shows up. And the way you always do these things is, I would always take this and plug it in and see like where you would roughly be. So if you take -2 and you plug it in, you get 0, right? That is the vertex. So at -2, you would get an open circle because it's strictly less than -2. It doesn't equal it, so you're not going to fill that in. And then, you could plug in some more points if you want, or just use what we know about the shape of this quadratic. But let's just plug in a -3. If you plug in -3, you're going to get -1, and then you square that, you're going to get 1. So at -3, you get 1, and I think we'll just kind of do that now. So it just looks like, half a quadratic because the other half is not drawn because it's not, it's cut off, I guess, right at the vertex. So that is one piece down. Let's do this piece here. So this is just a linear function, right? Graph between these 2 points. So it's going to be like a little line segment. And I would just draw, plot this point, and then connect the dots, basically. So if you plug in -2, that's going to be -1 minus 4/3, which we can just kind of use these little tick marks to figure out where that is. So -1 minus 4/3, so that'll look like over here at -2, you go -1, and then minus 4/3, we'll just drop another 1 and then a third. So, roughly speaking, it's kind of down there, let's say. Plugging in 0 is much easier because, you just kill that term and you just literally get minus 4/3. So that's minus at 0, here. You're going to be down 1 and a third. So we're kind of in there. And that one's an open circle, right? Because you're less than 0. So then we just connect the dots like that. So that's the second piece drawn. Third piece is really easy because literally it just says plot y equals 4 when x is 1, right? So at 1, right here, we're just going to plot 4. So we're just 4 right there. The last one, a little bit weirder. You got a base e exponential, so some sort of exponential growth thing, and that's for numbers greater than 2. So if you plug in 2, right, you get e to the 0, so that's a 1, and then you get 2 minus 2, so you get 0, right? What color do I want to do here? I'll do green. So at 2 you get 0, and it is open, right, because it doesn't equal 2 there. And so, we know it's going to be exponential growth here, and we could just kind of draw that in, but like maybe just to kind of get another point, just to see kind of the growth, we'll just plug in like 3. So if you do, 3 minus 2 in here, you're going to get 1. So we have like 2.7 times 2, which is roughly like 5.4-ish. And then if you minus 2 from that, right, you're like roughly 3.4. And so it's around there. It's not going to be perfect, but if you do, plug in 3, you're going to roughly be at 3.5 kind of here. So you get this pretty steep, exponential growth function right there. And it's just going to keep doing that, forever and ever and ever as you go to the right. It's just going to grow and grow and grow. So that is roughly what the piecewise function looks like. And then we can answer these questions. So we can either use the picture or use, this kind of stuff over here. For f of 0, if we use the picture, we can just look at 0. And we can just think, okay, what's the function value at 0? And, it's open there, and there's nowhere else that it exists. So actually, there's no solution. There's nothing that is f of 0, right? It's like a point that doesn't exist on a graph. The next one, though, f of negative 10, this is an arrow that this quadratic just keeps going, and you're definitely going to hit negative 10, like over here somewhere. So we're on this piece, right? You can just see negative 10 is less than negative 2, right? So we'll just plug in, negative 10 into that quadratic piece. And so we really get negative 8, and then we're squaring that, we're getting 64, right? So that's where we're at for f of negative 10. For the last one, a little bit weirder, it says, what is f of g of 8? And I tell you that g inverse of x is this cubic, okay? So what we really need to do is figure out what g is. I don't want g inverse, I want g. And so you kind of have to use g inverse to get g, right? And the inverse of an inverse is the original function there, right? So if we just calculate the inverse of this, we should have g. That's the idea. So same thing here. You just do that whole swap x and y thing that we did with inverses. So instead of y equals this function of x, we're going to have x equals 3y minus 1 cubed, right? And then we solve for y, and that'll be g, right? So cube root both sides, and then minus 1 and divide by 3. So we would have cube root of x, plus 1 to both sides, then divide by 3, and that would be y. So this is g of x. That is, the inverse of that as a function of x. So we can go ahead and solve now for f of g of 8. So if you plug in 8 to that thing, right, the cube root of 8 is 2 because 2 cubed is 8. So 2 times 2 is 4, 4 times 2 is 8. So the cube root of 8 is 2, and then 2 plus 1 is 3, right? And 3 divided by 3 is 1. So this is actually, I made the problem to work out next, but this is then equal to just what is f of 1. And we have over here, or you can see it here, f of 1 is 4, right? F of 1 is 4. And so we get 4. So this is very much like other stuff that you could see on the final. Definitely need to know how to do piecewise and also like function notation stuff, finding inverses. There's like a lot of important parts to that problem right there. All right, just going to do probably one more problem in this video, and that is just finding roots of a polynomial. And, we have 3 ways that we've sort of seen to do this, and those 3 ways are the U sub, the factor by grouping, and the rational root theorem. And you definitely want to know all of those. They all could show up in some way. For U sub, right, we need 3 terms, and we need the first highest exponent to be double the second one. But we don't even have 3 terms, so we're not going to do U sub. So that's not the way we solve this one. factor by grouping could work because you need an even amount of terms. But for factor by grouping, you want to take something out and of like each group and have another common factor in there. And I mean, there's not even anything besides x squared you could take out of like this group. That's not true. You could take 3 out, sorry. But 23 is prime, and I mean, basically the ratio of the numbers just won't work. You can't do, 23 to 45 and 9 to 15. That's not gonna help you here. So factor by grouping doesn't work, and so you really have to do the rational root theorem, not that kind of R, sorry. That kind of R. You need to do the rational root theorem. So the rational root theorem, right, is the one where, we have this P over Q kind of thing. And P is just the factors of 45. So, and plus n minus factors. So you could have 3, 5, 9, 15, and 45. I don't think I skipped any. And then Q is the factors of the first term, so the 9. So in this case, just 1, 3, and 9. Then what you do is, your possible rational roots are any like combo of these numbers. So, 3 over 9, a third, could be a rational root. 45 over 3, 15, could be a rational root. 5 thirds could be a rational root. Any of the negative ones of those, so negative 3 over 1, negative 3. Negative, 1 over 9, negative a ninth. The way, there's a lot in there, right? Because there's 1, 2, 3, 4, 5, 6, 7, 8, 9. I'm only up to 5 and these ones, right? So then you have all the negatives. You don't want to go and test all those to see what's a root. And so what I always told you to do is just use your graphing calculator for this stuff. So I showed you how to get a root on your graphing calculator. This is just a cubic, and it just kind of, it really does keep going up here. And then it kind of bends around and shoots off. And this part goes down forever. So yeah, it's a, just kind of a cubic like that. I think I'm going to erase that because it looks too cluttered. But you just use your graphing calculator, you can get a root. And in this case, if you use the 0 button on your calculator, you'll get negative 1.6 repeating, which is just negative 5 thirds. So negative 5 thirds is the root. And then we just do synthetic division, right, to reduce it. So we have 9, negative 15, negative 23, and 45. Those are just the coefficients, right here. We always bring the first one down. And then with synthetic division, basically what it feels like is just a lot of multiplying and adding, multiplying, adding, multiplying, adding all through. So you multiply these, you put that number here, and then you add. And then you'll have a new term, and you multiply this by that, you put that here, then you add. Multiply this and this, put it here, add. And we should get a 0 here because negative 5 thirds is a root. So it should divide in nicely, right? So if you go through and do all that, 9 divided by 3, so I'm just multiplying these two. 9 divided by 3 is 3. 3 times negative 5 is negative 15. So when I add those, I get negative 30. 30 divided by 3 is 10. 10 times 5, they're both negative. It's going to be positive. You get 50. What would that be? That'd be 27. 27 divided by 3 is 9. And then 9 times negative 5 is negative 45. So truly, they add to 0. That means that, negative 5 thirds is a root. Basically, it divided in. It has no remainder, right? That's what that means. Which is all good. You should have had that, basically. So now what this represents is you've basically just done long division, right? You've done this polynomial divided by x plus 5 thirds. And you get this quadratic. And so Now we just have 9x squared minus 30x plus 27 equals 0. And you just solve quadratic the way you've always solved quadratics. Like, I would divide by, what's the most I could divide by? 3, because everything's a multiple of 3. Just makes it a little easier. Probably wouldn't even bother trying to factor because a is 3. I would just go to the quadratic formula. If you do that, you're going to get 10 plus or minus square root of 100 minus 4 AC all over 2a. And if you simplify that down, you're going to get 8 and an I because it's really negative 8 in here. And so all that's over 6 still. So these two and then this, right, are the 3 roots to this cubic. And that all kind of checks out because, I mean, you can see one root. And then this part, right, where it kind of bends before it crosses again, that means there's like an imaginary root, right? Like if we ignored that part of the graph, this looks like a quadratic that has imaginary roots. So, yeah, 1 root, 2 more roots, 3 roots checks out. 2 being imaginary checks out. 1 real, we got that on a calculator, that kind of thing. So very important problem to be able to do. You definitely want to know rational root theorem and also U sub and also factor by grouping. All of them are super handy for tons of stuff in math.